Got quiz today.
You do?
Studied a little bit, actually. Not a little bit, a lot. I studied a very large amount. So we'll see how this goes.
Should be an easy one then.
I hope, man. I really hope. Have you ever made that ball to the backhorn before that game?
Nope.
Nope. What's the farthest you gone?
Mars.
Gotcha.
Mr. Townsend, I tried to access the video from Tuesday like 3 or 4 times, and it just would not let me watch it.
Okay. The other thing you could do is I also have a first period and a fifth period pre-cal. So if you watch those on the right day, that would be the same lesson. So.
Okay. Were there any papers handed out on Tuesday?
I don't remember. There was not.
Okay.
We worked with a book assignment, and then they studied for a quiz. So, did you know to study for the quiz?
Yes.
Okay. Okay, so we've got our basic trig memorization quiz, and you don't have to put your phones up on the side of the room for this. This is just a quick one. But you do need to go ahead and clear your desk off at least. And also, calculator needs to be put away. I don't see how a calculator would help you, but it's also not allowed.
Just get started.
Yeah, go ahead and start it. So some of it is matching, some of it is fill in the blank. All of it is how I warned you about on your notes. So easy one for you. But they're all 1 point apiece. No partial credit. And you might want to double check your answers the best that you can before you turn it in. Especially on the matching stuff. If you miss one of them, then I guess you'd almost automatically miss another one. So. Okay, so before you forget, your name needs to go on there. Numbered is 14. Double check the best that you can before you turn it in. And the turn in is the box up here. Doesn't look like anyone put their phone up, so, but if you did and I just can't see it, you can get it after the quiz. Again, you did not need to put up your quiz for this one. This is just a quick one we warned you about. late? Yeah, I have to go get an ID. See, hold on. You need to come get your quiz. I already passed out the quizzes. Sure your dust is cleared off and no calculator. And as you guys finish, just wait patiently, play on your phone or something for a few minutes to give everybody time to finish. So I don't think that does.
Commissioner?
The pass is out right now. Yes,
Do you do any form of retakes?
we do not.
Where do we put these?
In the basket.
Okay.
Thank you. Jonathan, you need to sit down. That's it. All right, so we've got 2 new handouts today, and both of these have to do with the stuff that you hopefully memorized. I told you that, I mean, you guys probably don't see it this way, but we feel like we're giving you a pretty easy quiz grade if you're willing to memorize those things, which you need to memorize them for what we're doing today anyway. So those of them that you didn't have memorized are going to make it a little bit harder. But this is the other half of section 4.3. So remember, it's in 2 parts. The first part is SOHCAHTOA, finding sides of right triangles, finding angles in right triangles, doing SOHCAHTOA ratios. That's what we practiced in the bookwork last time. The other half of 4.3 is doing trig identities, proving trig identities. And we have to have the basics memorized. But we're going to start off with this one that you picked up, the one that says beginner level. Because these are a little bit easier before we move on to the other handout. And you are more than welcome to disagree with me, but I think this is probably the toughest thing that we do the entire school year. And what makes it tough is you have to have the basics memorized, what you just quizzed over. And each of these questions kind of have a different approach to them. So I can't say, do this for step 1 always, and then always do this for step 2, and then always do this for step 3, and then you'll get your answer. We have to kind of think more on the fly here. But when we're talking about verifying or proving trig identities, this is not a true-false question. We're telling you everything on here is true. These are relationships that don't come up often, but since they don't come up often, we don't bother to memorize them. We can't memorize everything about trig, everything that's true. There's too many relationships in trig. But if we know the basics, what you're supposed to memorize, we can figure out if this is true in the future. This is true for sure for us on here. So it's our job to show. It's our job to show that the left and right side are actually the same thing. So these first ones start off as easy as possible. Brody, you need to put your phone up. So we've got to do some mixture of algebra mixed with the trig identities so that we can make this left side look different and different and different until we show that it's the same thing as 1. So these can also be kind of frustrating because like here you might call this, instead of saying tangent, we might call this what?
1 over cotangent.
Okay, that's a good guess. What's another way to say tangent? Because I want to do it the wrong way first.
Sine over cosine.
Okay, so technically tangent is sine over cosine. So there's nothing wrong with trying that step. The problem is if you try that step, you still get stuck. So in that case, you've got to try something else. We could either maybe rewrite cotangent in a different way, or maybe instead of saying sine over cosine for tangent, what if we said 1 over cotangent? And then do you see how the times cotangent divide by cotangent cancels? And then we have shown that the left side is in fact equal to 1. So plugging in a reciprocal identity in one of those two and then simplifying it shows that you get 1. Yeah. They're on the front desk. The handouts will always be on the front desk when y'all come in. Unless I forget, and if I forget, I'll pass them out to you. Okay, so to do the same thing for question 2, we could try to rewrite cosine or we could try to rewrite secant. So there's not much you can change cosine into, but what could you make secant look like?
Well, you can do 1 over secant for cosine, right?
Okay, you could do that instead if you'd rather, sure. This is 1 over secant. So again, some students tend to think that these can be kind of frustrating, but on the other hand, you can solve these multiple ways. I was going to change this into 1 over cosine, which would also work, but I have shown through algebra and or trig identities that the left side is the same thing as the right side. Now, the most common mistake before we keep going here is that this is not solving an equation. So if at any point you add, subtract, multiply, or divide to both sides of an equation, it is going to be incorrect. You need to leave one side alone. Sometimes when you divide both sides by an equation, you can make things look true that are not true. So leave one side alone. Never add something to both sides. Never multiply something to both sides, because that is not the point of these. Okay, so typically you choose to work with the more complicated side, which just happens to be on the left most of the time. But if you'd ever rather work with the right, you're welcome to. So looking at this, how could we change one of these two? Okay, so you could try tangent is sine over cosine. And on the harder questions, you're not going to be able to see the whole process. Sometimes you just have to try something like that, put pencil to paper, and then you can see if it's helpful. If it's helpful, then stick with it. And if it didn't help, you might have to erase it and try a different approach. Okay, one more like this, and then I'm going to bump up the difficulty. So instead of saying cotangent, what's a different way to say cotangent? One more time. Okay, cosine over sine. Cotangent's also 1 over tangent. So whichever one looks useful. I'm going to leave this one alone. And so I've showed that the left side is always cosine and the right side is always cosine. So as we go through these questions and as we bump up the difficulty, we need to try to create like a toolbox of things to consider. So far in questions 1, 2, 3, and 4, we saw change in tangent in the sine over cosine, cotangent in the cosine over sine, and sometimes using the reciprocal identities, like cosine's 1 over secant or tangent's 1 over cotangent. So again, this is, you're starting to see why it's so important to have these memorized. If you don't have those memorized, then there's no chance you're making that substitution. Not to say that you couldn't maybe figure it out a different way, but most of these questions usually have one way that's a little bit easier. Okay, I'm going to give you a little different tip on question 5. For this one, I'm going to ask you to add to your toolbox when you get stuck on a trig proof and nothing else jumps out at you, nothing else that you can try. One solution that always works is to change everything in the sines and cosines. So if we change this and to what he's equal to in terms of sines and cosines, and change this into what he's equal to in terms of sines and cosines, and this guy is already in terms of sine, so I don't need to do anything with him. Mathematically, changing everything in the sines and cosines always works. But you really should use it as a last resort, because students who always just change everything to sine and cosines are going to make some questions way harder than they need to be. Okay, so now that I've changed these, do you guys see why the cosines need to cancel out? And why the sines would have to cancel out? So I have shown that the left side is in fact always 1. So identities like reciprocal identities and quotient identities, and then question 5, sometimes you want to change everything in the sines and cosines. Okay, but we haven't really done much algebra stuff, and there is a lot of algebra mixed in with these. So looking at question 6, in algebra class, when you have 2 terms like this times 2 terms like this, what do you normally do with those? Okay, distribute, and also called FOIL? Your teachers didn't use the word FOIL? Okay. So I don't know that FOIL is going to do this, but to me, if there's 2 things times 2 things, there's a good chance it's FOIL. So we go ahead and FOIL these 4 things together. And again, maybe it's helpful, maybe it's not helpful. If it's not helpful, I can always erase it and try something different. But now that I FOILed those, I can see that there's some like terms that cancel out and go away. And it leaves me 1 minus sine squared. and somehow this is supposed to be equal to cosine squared. Now this is actually an easy last step, but it's not obvious at first. So one of the things that you hopefully memorize for your quiz, and I recommend that anytime you need to do trig proofs, which is just a couple times this semester, just write these three down on the top of your page. There's the first Pythagorean identity. You can find the second one by dividing everything by sine squared. And you can find the other one by dividing them all by cosine squared. I really think doing that carefully once at the top of your page for you to look up and glance at is beneficial. What I need you to look at for this question is notice how this looks similar to this. So even though I cannot add this over, we're not allowed to add, subtract, multiply, or divide, we're not solving an equation, I can visualize this and I can manipulate it this way. Do you see how if I leave the 1 here and I subtract the sine squared over, what is 1 minus sine squared equal to? It's going to be equal to cosine squared. So in place of 1 minus sine squared, I can just say cosine squared. That's considered a basic identity, so I don't have to prove that that's true. You have to have that identity memorized well enough that you can recognize it and make that substitution though. So once again, all of the basic identities that you were supposed to memorize, like the 3 Pythagorean identities, you never have to prove these to us. These are ones that you can use because we all just agreed to memorize the same ones. Okay, so question 7. Again, if you saw this in the other worksheet at some point, 2 terms times 2 terms, we just saw foiling works. So maybe foiling works again. Certainly a good start. So try that, and then what happens after that? One more time. What should we do next? Okay, we've got some like terms that could add to 0. And then, if you have this still written at the top of your page, you can visualize if you took 1 and subtract cosine squared over, 1 minus cosine squared is equal to sine squared, which is what I need it to be, so now I can move on. Once again, I'll try not to say this to bug you too many times, but I don't have to prove that this is true. I have to know these well enough that I can make those substitutions though. Okay, and then one last time. So 2 terms times 2 terms is probably FOIL. Just like the last 2 questions, we had some like terms cancel out. Try to make sure you're showing all of your work, because again, that's the point of these questions. We are telling you that it's a true statement. We know it's a true statement. We're trying to show the algebra and the trig identities to prove that it's a true statement. You get down to this. Okay, and now let me show you the bad idea that would still give you full points, and then I'll show you the smarter way. If we put this on a test, somebody's going to do this. They're going to say, well, I don't know what else to do. Let me, again, you don't have to copy down the rest of this, but let me rewrite this in terms of sines and cosines, and this in terms of sines and cosines, because I said that as a worst case, changing everything in the sines and cosines will work. And you're going to see when we jump over to the right side, sometimes we have to add and subtract fractions. But this one already has a common denominator, so that's okay. And then this should start to look familiar to you now, because this is already the third time we've seen it in 8 questions. What is 1 minus sine squared equal to? Cosine squared. And anything divided by itself is 1. That's perfectly fine. You do that on a quiz, I'm going to give you full points. But what would have been the smarter thing way up here to do? Yeah, especially if you have these written down. Secant squared minus tangent squared is equal to 1. It's perfectly fine to go from there to there and be done and skip all of that. Basically what I just did is I proved why this is equal to 1. But once again, you don't have to prove any of the basic stuff. You need to know the basics really well so that you can do it as efficiently as possible. Again, there's nothing wrong with doing it the left way, other than it's more frustrating and the question's longer. And the longer you make the question, the more likely you are to have a careless mistake. But both ways would still get you full points. Okay, so before we go over to the other 4 on the right, let's kind of recap the stuff that we've talked about, because when we get to a harder question that you get stuck on, you have to have things to consider. So, sometimes reciprocal identities, sometimes quotient identities, sometimes changing everything into sine and cosines, sometimes foiling, sometimes Pythagorean identities, sometimes foiling, sometimes Pythagorean identities, sometimes foiling, sometimes Pythagorean identities. Or change everything to sine and cosine and make your life hard. So, as we go through the other ones, those should be the things at the top of our list to consider when we get stuck. Okay, 9 is another jump in difficulty here. So we're trying to make all of this look like that. So any algebra that you've ever learned is fair game to use, but also any of the basic identities we've memorized are fair for substitutions. But what jumps out at me about this question that gets easier for you is, notice on the left side we've got sine squareds and cosine squareds, but on the right I've only got sine squareds. That's my hint that this is the thing that probably needs to change. So let's leave sine squared alone, and we need to think of some way that make cosine squared look different, and specifically we'd really like it to be in terms of sine squared. So if you have this at the top of your page where you can quickly glance at it, you could look up here and say, well, cosine squared is the same thing as 1 minus sine squared. Let me try to plug that in. And if that thought can cross your head to make that switch, you're probably going to be able to get this one right. Because now it's just distribute the negative and combine your like terms. Sine squared plus sine squared would be 2 sine squared. Also, just so you guys know, on a trig proof, if you don't write the other side, it's implied that you're just carrying it down. You don't have to write it every single step, but you should have the last step down there. So again, what's tough is that you may not see this type of question again for 10 or 15 questions. Not every problem needs this. But what I saw was this had sine squareds and cosine squareds, but I only want sine squareds. So that was my hint that this needed to change. And with the first Pythagorean theorem, I knew it was equal to this. And so once you consider that, it's probably not going to come to you instantly, but once you consider that, then the rest is pretty straightforward. Okay, another trick. Another algebra skill, just to kind of jog your memory, is when I look at number 10, the big difference is the left side has 2 terms. Terms are things being added or subtracted, but the right side only has 1 term. So I need to force these together somehow. So if there's some identity to force them together, then that's fine. You might be tempted to call this tangent and to call this cotangent. And that's not wrong, it's just not helpful either. So if you go that route, you're going to get stuck and have to try something else. But another way to force these things together is with adding fractions and common denominator. So right now, this is what the left fraction looks like. And here's what the right fraction looks like. So between these two denominators, it looks like the least common denominator needs to have a sine and a cosine. This one has a cosine but not a sine. So I want to include that in his denominator, but you can't just multiply the denominator by sine without multiplying the numerator by sine. Multiplying both is like multiplying by 1. Over here, this guy has sine, he needs a cosine. And the whole purpose of us getting a common denominator when we add fractions is it allows us to shove it together as one big fraction with that common denominator. Here we've got sine times sine, which is sine squared. And here we've got cosine times cosine, which is cosine squared. Well, what is sine squared plus cosine squared? It is 1. Does everyone know why that's 1? First Pythagorean identity. So, in place of that, you can say 1. And then we've got two reciprocal identities. 1 over sine gives us the cosecant we wanted. And the 1 over cosine gives us the secant we wanted. Same as it was at the beginning. So again, you don't have to get a common denominator and add fractions often, but you will have to do it sometimes. So what jumped out at me about that question to make me even consider doing that is there was 2 terms on the left, only 1 term on the right. So one way to force these 2 things together was by adding those fractions together. So adding our fractions together has to be one of the things we consider when we get stuck on a question here in a bit. Okay, and then the last 2, we can start off with a similar, or the last 2 have a similar first trick at least. With fractions, one of the easier ways to move forward on these is to split them apart. So I can put secant squared over secant squared, as long as I also put the 1 over the secant squared. You can always split apart numerators like that, not denominators, but numerators. Fractions don't work that way with denominators, but they do with numerators. It's basically like you're undoing subtracting your fraction. You're used to going from here, that direction, but we're just going the opposite direction now. And so if you consider splitting apart your fraction, what does all of this become? Because anything divided by itself is 1. 1 over secant is cosine, so 1 over secant squared is cosine squared. And now you can start to see, hopefully, how this gets a little bit easier, because we've seen this pattern a bunch now. You glance at the top of your paper, and 1 minus cosine squared is the same thing as sine squared, which is what I needed it to be. So splitting apart that fraction is one of the nicest ways to start some of our questions. So once again, this is just a tool to use. So when we jump over to the other worksheet, we don't know how to start a question. If we could split apart the fraction, that's something worth trying because it worked here. Okay, and then one more. And then on the next worksheet, the questions aren't, the difficulty of the questions are kind of mixed up. On this one, I kind of put them from easiest to hardest. But if in question 11 splitting apart the fraction worked, then in question 12 splitting apart the fraction might work. So let me try to put tangent over tangent. Notice the angle doesn't really matter. The angle could be theta, it could be t, it could be x, it could be b. It doesn't really matter as long as it's consistent. Again, I don't know if this is going to be good. I just have to start with something. So I split apart my fraction. Anything divided by itself is 1. Now, does anybody know what this is probably going to simplify to here? Any guesses what that might simplify to?
Tangent.
Did he say tangent?
No, I said cotangent.
Okay, cotangent squared to be specific. So I'm going to guess that she might be seeing that from one of the 3 Pythagorean identities. Looks like this. And 1 plus cotangent squared is cosecant squared. So you're right, this is probably going to be cotangent squared. But it's our job to show why that's true. So this is not a basic identity. I didn't ask you to memorize that cotangent divided by tangent is cotangent squared. So you can't make that jump if it's not something we memorize. So what did I say was kind of like last case if nothing else seems to be working? Okay, and then I'm going to come back and show you a slightly smarter way. But if you're not sure how to make this look different, change this into sines and cosines. Fraction bar means division. Change tangent into sines and cosines. The way we divide fractions is by doing the keep, change the sign, and flip. You getting this down, Jonathan? You'll have to go back and get it later. Okay, so we end up with 1 plus cosine squared over sine squared. Which is cotangent squared, which I kind of predicted. But again, we have to show it some way. Now, this is one of the biggest mistakes that you guys will make, other than trying to make it like an equation you're trying to solve. A lot of times on a quiz, and I say this every year, and then there's still people who lose some very careless points. They stop right here. The problem is, if you stop right here, it looks like you don't know that this is cosecant. Your last step in all of these really should be the exact same thing on the left and the right. So once again, if you leave that off, to me it looks like you get stuck and I can't give you full credit. You need to show that, hey, I think this is equal to cosecant. So that's the long way, but it works. I changed this stuff into his sines and cosines, this into its sines and cosines. I divided those fractions by changing it to multiplying by the reciprocal. I multiplied those fractions, it was a quotient identity, and then this was a Pythagorean identity. But there was a much quicker way that I'll show you that you can kind of try to rely on so that hopefully you don't have to go through all that. Right up here, I could have said tangent divided by tangent is 1. Anything divided by itself is 1. And then what I'm about to say is really the same thing that I just went through right here and all of these steps. Dividing by tangent is the same thing as multiplying by what? Right, dividing by something is the same as multiplying by his reciprocal. So dividing by tangent is the same thing as multiplying by cotangent. So this could also be read as cotangent times cotangent. And so if you're really paying attention there, notice that you could skip about 3 or 4 of those steps. There's nothing wrong with what I did the first time. It's just lengthier, a little harder to achieve. But dividing by something is the same as multiplying by its reciprocal. So if you catch that, sometimes you can save yourself a little bit of heartache there. Okay, so all I need you to get out of this first handout is what a trig proof looks like. Know that you need to leave one side alone. Make sure you finish the question. Make sure that you don't quit until the left side and the right side say the exact same thing. And to add some ideas of how to get you unstuck when you get to a question you don't know how to move forward on. So whether that's reciprocal identities or quotient identities like the first few questions, changing everything to sine and cosines like the fourth or fifth question, foiling and Pythagorean identity like the next few, or changing what you have into what you need like question 9, or adding our fractions to go from 2 terms to 1 term like question 10, or splitting apart our fraction on 11, or splitting apart our fraction in 12. We're using a lot of the same techniques. So that's what's going to carry over to the other handout because it's going to be different trig proofs. So I am going to let you do some of this at your own pace, but not quite yet. But let's jump over to the other one. Oops. Look at that. Now again, these vary in difficulty. So question 5 might be easier than question 4, for example. But I want you to take, because it's real easy to just let me say what to do, and you can follow along and be agreeable, but until you have to try something on your own, it's a little bit harder to figure out how to start. So I'm going to give you 2 minutes to try question 1, and if you get stuck, look at the other handout and see which technique you can steal from. But if you finish, you should probably know if you did it right, and then you're welcome to move ahead a little bit if you want. But 2 minutes for question 1, and then we'll go over it. We're going to do just a couple like this with guided practice, and then I'll let you work a few at your own pace. And we're also going to practice more of this next class. This is not a skill that everyone masters in one class period, so we're just trying to get some growth. So there was 2 minutes. So, as frustrating as these questions can be, it's also kind of nice because assuming you're not making up some kind of math that doesn't always work, you're not working with fractions in a way they're not supposed to work, you're not making a trig substitution that's not really true, you should know if you did it correctly because you got the left side and the right side to say the same thing. So, somebody who thinks they did it correctly, can you tell me what it was that you started off with?
So you do 1 over cosine
Okay.
plus cosine over cosine.
Okay, so it looks like he split apart his fraction. We saw that work on a few on the other worksheet, so it might work on this question. You never know until you try it though. Don't try to visualize the whole problem before you write something down. Okay, and then 1 over cosine ended up being, which is good because I needed that.
Cosine over cosine is just 1, so plus 1.
Yep. Anything divided by itself is 1. So some of them can be as little as 2 steps. And it's okay not to know what to do right away, but at some point in your thought process, you should have thought to split apart your fractions, because we've seen that work in the past. Okay, make corrections there if you need to, and then if you've not done question 2 yet, because I know some of you can work a little bit faster than that, take 2 minutes to go through question 2. And same thing, if you get stuck, look at the other worksheet and try to steal some strategies off of it. Think about what's worked in the past. Okay, so this one should have gone a little bit smoother for you. More of you should have figured this one out. Because in question 1, we split apart our fractions, and it worked. So if nothing else, you should have tried to split apart your fraction in question 2. Again, it's fine if it's not the first thing you thought of, but after a minute, you've got to try something. This becomes 1. Anything divided by itself is 1. 1 over cosecant is sine, so 1 over cosecant squared would be sine squared. That's a reciprocal identity. And then if this is supposed to look like cosine squared, that looks very familiar. Once again, I really suggest you guys do the Pythagorean identities once, very carefully at the top of your page so that you have them to visualize. But you only need the first one for this. 1 minus sine squared is cosine squared. You don't have to show why that's true. You only have to recognize the identity and make the substitution. Okay, anything specific about 2? Okay, I'd like you to do one more with this on the board, and then I will tell you the other ones I want you to do from the front page before you move on. So try question 3. And see how close you can get. Okay, so the reason why I really wanted you to try question 3 is because I wanted you to see if you fell into this trap. If you said question 1 and question 2, splitting apart the fraction works, then maybe in question 3 I can try to split apart the fraction. So if you try to put this over 1 and put this over sine squared, you get sine squared minus 1, and fractions don't work this way. So if you take that path, you did something that's not correct, you're never going to get this to look like this. Sine and secant aren't the same thing. So you may split apart the numerator, but not the denominator. In fact, I'll give you a couple numeric examples here to show you why this is okay. In a numerator, if I try to do something that we know the answer to, like the answer to this should be 4 over 4, which is 1. That's the correct answer. It works to split apart your numerator. You could put 3 over 4 plus 1 over 4, because you still end up with 4 over 4, which is 1. Splitting apart your numerator works. But if you try to split apart your denominator, let me do it like this. The real answer to this question is 1. But if you try to split apart a denominator, you're like saying 4/3 plus 4 over 1, which is 4 plus 1 1/3, which is like 5 1/3. 1 and 5 1/3 are very different. You can split apart numerators, not denominators. But I could see why you might try that. Okay, so if that didn't work, can somebody share what this may be something else you could do to rewrite this?
Sine squared divided by cosine squared.
Okay, I'm sorry, one more time. Sine squared what?
Sine squared divided by cosine squared.
Okay, so you're changing this to cosine squared, right? So to me, that's pretty obvious, but again, I've done a lot of these before. 1 minus sine squared is a version of the first Pythagorean identity, and it is equal to cosine squared. So if you try that, sine over cosine would be tangent. If they're both squared, it's tangent squared. And then if you have your 3 Pythagorean identities written at the top of your page, it's a lot easier to see, but it's fine. I'll write them again. So you've got the first one, and then one of the other ones looks like this. So it looks like tangent theta is equal to secant squared minus 1. I don't need to prove that's true, I just need to make that connection. That's all you needed. Change the bottom with Pythagorean identity, change sine squared over cosine squared using a quotient identity, and then finish with another Pythagorean identity. So if nothing else, you should see how important it is to know these identities. If you don't know that identity, you're not going to know to make this substitution at the end or that substitution in the middle. You may not know to make this substitution to that. Okay, so the ones that I would like you to do on the front page would be 4, 5, 6, and 7. If I remember correctly, 8's the hardest one on the whole worksheet. So you're welcome to try it today, but make sure you do those 4 first. And eventually, when it looks like everyone's had time to do all 4 of those, I will go over those 4 on the board. And of course, you should know which ones you got and which ones you didn't, so you can just pay attention to the ones you need to. But before I totally let you go there, I do want to look at our daily meme here, because one of these is similar to a trig proof. Not the bottom one, but did y'all figure this meme out?
Code tangent. Tan K on the bottom.
Sine over cosine is what?
Tan is K.
All right, sine over cosine is tan of k. Tan k.
Take.
Okay, and then this one's more like a trig proof. It's an easy one. If tangent sine over cosine, do you see how the cosines could cancel? And what would that leave you when the cosines canceled?
Sine K.
sign K, or send K, which is sync. So I've never seen that one before. That's like most of the memes I've used in past years. So, but I thought those were pretty clever. So, all right. So try all the questions on the front page. Skip number 8 for now if you want to. Once you're done with those, move on to the back. You do not have to finish this worksheet in class, and you don't even have to finish it for homework. So I'm going to go over all 4 of these. So try the one at one first, and if any of them are not working out, you can watch the class videos where I go over them. And I'm going to ask you to do some of them in the back. But I would probably think that's the easy ones. Like a lot of people try this one because it's first, but it's not as easy as this. Try to get a couple more done. Okay. Have less for next class. Even though I'm going to go over all 4 of those on the front with you, if you need a hint or something, I would be happy to help out. But there should be similar skills. Diagram identities, splitting apart fractions. Lots of the same things in a different order. While you guys are working on that, I'm going to pass back your first quiz, your 4.1 quiz, now that everyone's had time to come and take it or make it up, even if they got in the class late with the schedule change. And of course, I don't mind if you glance at it, but don't get too distracted from what you're doing. If it's going to distract you too much, I'm just not going to pass them out during class time in the future. But I'll also say that if you did well or you only missed a few questions, a few points, I probably wouldn't worry about it too much until we get near the test. And if you missed a bunch or you did worse than you expected, you might want to start looking at it 5 or 10 minutes a day just to make sure you learn from your mistakes, since this stuff will show back up on the next, or on our first test. We can have a test. You got the front end? Done. I'm going to start to talk about these, but again, you should know which ones you need to pay attention to. I guess if I'm cutting you off on time here, you can ignore me, but you will need to, between now and next class, which is next Tuesday, need to go to the class recording to this part of it so that you can kind of learn from your mistakes here. Okay, so in question 4, I would say, again, it's hard to say the thing to do because you can work some of these questions multiple ways, but I would say probably the best approach would be splitting apart your fraction on this one. That just works too often to not try it. This becomes 1 because anything divided by itself is 1. I know I need a -1 and a -1, so I know this is going to come out to be cotangent. But even if you guys think you got this one, you need to make sure that you didn't go from this straight to cotangent. This is not a basic identity. I didn't ask you to memorize that. If you ask me what cosecant divided by secant is, I don't know off the top of my head. So probably the only way for you to show that is to change this into 1 sine and change this into 1 cosine and show that if you divide these fractions, you get cosine over sine, which is cotangent. Again, the whole point of these questions is for you to show that they're equal. So if you're skipping too much work, if you're fuzzing some of your algebra to make it just look like it's right, then that's not really worth much. You're missing the point of the question there. Okay, did anybody have any quick questions about 4? Any of that I went over too quickly? Okay, then even if you didn't need that one, you might check 5 real quick. So when I look at 5, almost everything on the left is in terms of sines and cosines, so I'm just going to finish that. Sine squared's already in terms of sines, cosine's already in terms of cosines, but instead of saying secant, we could try 1 cosine. And then I can see that these cancel. Honestly, I haven't even looked at the right side yet, but at some point you got to peek over to the right side to see where you're aiming for. And then this looks like the first Pythagorean identity. So you go up to that at the top of your page, solve it for sine squared. Sine squared is the same as 1 minus cosine squared. You are welcome to just make that substitution because that's a basic identity. Again, that's not the only way to do that, but that's probably the most efficient way. 3 steps is pretty short, especially when the last one's just saying that we're finished. Does anybody have a specific question about number 5? Okay. Then on number 6. Number 6 is probably the hardest of the 4. This is the one that most people needed to pay attention to yesterday. I have 2 pre-calc classes on A days. So, I'm going to leave sine alone. I might leave cosine alone for a second. And instead of saying cotangent, I could try cosine over sine. I think that's the most common first step for people. But then a lot of times you guys get to this and then you're not sure what else to do. So, I mean, I guess I could at least multiply these 2 fractions. This would be cosine squared over sine. And it's normal for you to slow down or get stuck here. But on the other page, there was one time where I tried to phrase it this way. This side has 2 terms, that side has 1 term. One way to force these together, if it doesn't fit an identity, is to try to get common denominators. So you got to multiply the numerator and denominator by the same thing so that you can throw all of that together under that one common denominator. And if that crosses your radar of things to try, then you're probably going to feel pretty confident right after that, because in the numerator is the first Pythagorean identity, which is a good sign. And it becomes 1. Sine squared plus cosine squared always equals 1. And that's what we need, 1 over sine. So once again, I'm not saying that you have to add fractions on every one of these questions, but if you get stuck someday, that's something to try. That's one trick that works on some of the questions. Okay. Anything specific or details about number 6 before I slide it away? Okay. Then the one other one, I'm going through these a little bit quicker. Number 7. And number 7 should feel quite a bit easier. Again, it doesn't mean you know what to do instantly, but at some point you should say, well, this is basically a reciprocal identity. 1 over secant is cosine. So 1 over secant squared would be cosine squared. And if that ever crosses your head, then you're probably realize you're almost done, because now, for about the 10th time today, a version of the first Pythagorean identity. Look at the top of your page, solve it for 1 minus cosine squared, and see that it's the same as sine squared. As I mentioned on our first page though, don't do this. If you do this on a quiz and you stop there, it looks like you got stuck and you didn't know what to do. And I think 9 times out of 10 people do know what to do, but I can only grade what you write down. You need to show this is sine squared and that's sine squared. Your last step should really be the same thing on the left and the right. Alright, so I am going to ask that you try a few of the questions on the back for homework. You'll still have about 8 minutes, so you don't need to pack up just yet. But you don't have to finish the back page. So try to find a couple on the back page that look easier than the others. I don't think 9's the easiest one on the back page. I'm not telling you not to try question 9, but there are certainly easier ones. So identifying some that look shorter or more obvious how to start is good and part of the learning process. So try to do a few of those between now and next Tuesday, and then we'll practice some more of this on Tuesday again. So. Also, those quizzes I passed back to you guys, again, if you only missed a few points, I wouldn't worry about it too much until we get closer to the test. If you missed a bunch, you might want to start looking over it, comparing it to your notes, comparing it to your homework, try to learn from your mistakes. Maybe sign up for a prime time if you have specific questions. But please, please, please keep those. You should have a spot in your binder to put those. When we get near our test, our #1 resource is going to be your past quizzes. Anything that you missed on that first quiz, actually everything on the first quiz, you should expect on the first test. So anything you missed on the first quiz is something that we need to try to fill in the gap for our first test. So even if you aced it, or you did awful, or anything in between, make sure you put that away in your binder where you can find it. That's going to be real important to you in a couple weeks.
What number would this be? This be 11?
I don't remember. That's why I tell you to number them. On our website that you have bookmarked, you know the agendas are in the top right.
Sure. I can check that.
I have it pulled up, so I'll look for you this time. But in general, you need to look like it was number 6.
Number 6.
Yeah, that's what I mean by if y'all don't number them the day that you take them, you're not going to know where it fits in your binder because it takes a week or so to get them back.
Is the 4.3 book assignment going to be due Tuesday?
You should have the 4.3 book assignment completed. I will give you one chance to ask last questions next class. So I know I have the videos worked out online, and that should help you with 99% of your problems. But I know some of the videos are better than others, or something can come up. So I'll give you a chance to make sure you don't have any final questions next class. But I usually don't take up I usually don't make things due until quizzes are ready, so. Yeah, if you guys notice on the agenda up there too, the homework doesn't say that you have to finish this trig identities worksheet, but it does let you know that you need to finish the bookwork. I know you guys got pretty close last class, but you need to try the rest of those. So if you need help, you know what that is at the start of next class, because that's going to be your chance to ask. Okay, and now we've only got about 3 minutes, so now would be a good time to find a stopping place. If you borrowed a calculator, please bring it back.